so we've got two runners who start the race at the same time, okay? And we've got a velocity time graph, shows their velocities over the first 5 seconds. So you can see here, del is a nice constant straight line there, okay? Whereas Catherine has a curve for her velocity, okay? So it says then, after the start of the race, what was the earliest time that Catherine's acceleration was 0 meters per squared? So if we look at Catherine's, the curve here, okay, the acceleration will be 0, okay, where the curve starts to flatten out, okay? In fact, if we were to draw a tangent at that point in the curve, it would be horizontal. So if you could see here at the top here, okay, where the curve sort of stops increasing now, okay, and it's flat there at that particular time, isn't it? If I was to draw a tangent there, it would be horizontal, wouldn't it? Touching the curve right at the very top, going across, okay? So that's where the velocity stopped increasing, so that's where the acceleration is 0. So at that time, that would be 1.7 seconds, okay? So that's what we're going to write here. In part B then, it says, use the trapezium rule to calculate an estimate for the distance Catherine covered in the first 5 seconds of the race. And it says use Catherine's velocities of those times. So these are what we call our ordinates, okay? And what I'm going to do, I'm going to draw lines of these for you to see that they are actual trapeziums, okay? That we're going to create. Because if I draw my lines at those particular points, all the way up to 5, and then you can see then trapeziums are being created. In fact, the first one is a triangle, isn't it? Okay. But the rest clearly are trapeziums when you turn it on its side, all right? So we need to use this formula, okay, which is on the page 2, okay, given to us. So we just copy it down there, and then if you want, you can call these sections A, B, C, D. Okay, and E. So area then of A, okay, will be, well, we've got half. Now I need to add A and B, right? And remember, A and B are the two sides that are parallel, okay? So these are the sides that are parallel, aren't they, all along here, okay? So the A, in fact, there's no side there, isn't it, because it goes to 0, so that would be 0 for A. B would be this side here, which goes all the way up to 4. And then you times it by then h, which is the height between them, okay, between the parallel sides, which is just 1 in this case, isn't it? You can see on the scale there, okay. So we work that out, okay. Half times 4 is 2, times 1 is 2. Do the same then for B, okay. Well, this one you can see much clearer as a trapezium, and if you can't, as I said, just turn it around, and we've got then those two sides which are parallel, okay. So you just need the length of those two sides times it by then the distance between them, okay, of course half in front as well. So this side here is 4, okay, this side here is 5, okay, times then by 1. So if I work that out, well, 4 plus 5 is 9, okay, half of 9 is 4.5, times 1 is still 4.5. Do the same then for C, okay, so we've got half, right, so for C, the first side is 5, just as before, plus then that side, which comes out to be 4.8. Okay, so we've got a little bit of work to do here to do the calculation. So if I work this out here, well, I'll take my time, half. 5 plus 4.8 is 9.8, and then times 1. So half of 9.8, if you halve 9.8, you get 4.9. Okay, so D then. So we've got half. That side, remember then, is 4.8. That side there is 4.2, I think, on the scale there, times 1. Okay, so you get then, well, half there. Those two added together will be 9. And then times 1, so you get 4.5 here. Okay, and then E then, the last section. Well, for E, if we go there, you can see that that side there is of length 4.2 as we had before. And this length here is of length 4 exactly. Okay, so times it by the, remember then the height between them is just 1, it's the same for all of them. So that will be, well, 4.2 out 4 is 8.2, times 1, so you get 4.1. So all I've got to do then is, right, is to add then these areas together. And remember, the area gives you the distance, okay? That's how it works. So if I add these together, so the area, which equals the distance, which essentially then equals to 2 plus 4.5 plus 4.9 plus 4.5 plus 4.1. Now in my head, I'm thinking, let's add these two together first, because 4.9 plus 4.1 will be 9. Okay, 4.5 and 4.5, add them two. Okay, so add them two, group them like that. So that's 9, that's also 9, so that's 18, plus then that 2 is 20, okay, and it's measured in meters, okay, from the graph we can see that. So total of 20.